Hi, it's Chad with Central Heating and Air. I just wanted to show you guys what saturated products are, and this also involves kind of some thermodynamics and just real basic, easy stuff. So, liquids such as water, refrigerants, um, they all follow a pressure and temperature relation. So, um, the saturation point is what I want to show you though. So, right now I can take the water and let's see how many microns it takes to boil it. Let's see if we can get the backlight on. Micron. Okay, here we go. I'm gonna start it up. And we are boiling water. That's basically room temperature at 19, I don't know, 1900 microns. It's boiling pretty good. And that's probably about 75 degrees. I just have some putty around it to seal it. But yeah, check that out. Isn't that pretty cool? But the reason it's boiling is I took the atmospheric pressure off. And that's the point of doing a vacuum pump in a system. So, relating to that, if I come over to a tank, as long as I have a little bit of liquid in the bottom, here, let me show you on this one. If I have a little bit of liquid on the bottom, or 30 pounds of liquid, it doesn't matter. It's going to follow the same temperature pressure chart. So I don't know what liquid is in this one, to be honest. We're about to find out. So it's about 62. This might be a little warmer because we had a temperature drop, so maybe 65. I don't know. Let's see. 65 pink. So that would be R410A. Now let's do the R22. I don't cross-contaminate my gauges. Okay, so I would not use the 410 on the R22. I just keep them separate. So let's see what the R22 does. Turn it on. Whoops. Gotta close this. Okay, so we'll turn it on. And I'm about, 62, 63. So you can see the green reads. Can you see that one? Yep. So anyway, the reason they're doing it, it's just their thermodynamic nature. The saturation point, that's where this will change state. When it goes above or below, is compressed or released. If I were to release a whole bunch out and then put this back on here, that would be a lot lower. This would be a lot colder because it gave up its thermal energy. It's basically just thermal energy. So I guess it's kind of like a sponge. It can only soak up so much. If I were to take this water into the freezer, it'll go down to 32, and then at that point it'll take a long time to freeze, and then it'll continue to get colder after 32. But so 1 BTU is 1 pound of water. I'm sorry, 1 BTU is the amount of heat it takes to heat 1 pound of water 1 degree. And that's kind of their calculation, just like 1 inch is 1 inch. It's just the standard. So anyway, it's just a standard measurement. So if I were to take this at 35 degrees, put it in the freezer, it'll go down to 32, remove a BTU. 33, remove a BTU. It'll go down to 32, remove a BTU. Now, it won't go to 31 by removing 1 BTU. I'm going to have to remove maybe hundreds of BTUs to change the state. That's where people don't understand. And same with it works the same with vapor. If you're going to turn something from a liquid to a vapor, um, it's the same thing. It's a lot of thermal energy transfer. So that's how we transfer with refrigerants and transfer so much. I guess leave any questions, and if you have any, thanks.